Welcome to this class. Today we will be looking at sound waves, and we shall begin by looking at a few things. Sound is referred to as a mechanical wave, and because it requires a propagating medium, that is where we are saying sound is a mechanical wave, because it must require some material where it has to pass through. So some of the materials or the medium through which sound travels is a solid, is one of the categories. The other one is the liquids. The next one is the gases. So those are the three mediums through which sound can be able to travel. So we can move on and say, we can say that a wave is produced by the vibrations of the particles of the medium through which it passes. So basically it means for sound wave to travel, it requires some material, it requires some particles. And we have said before that sound, of course, comes from vibration of particles. So meaning, for sound to travel, it requires vibration of particles. And that is why we are saying that a wave is produced by the vibration of the particles of the medium through which it passes. So if the medium does not have particles, then of course you don't expect sound to travel through that particular material. So essentially we are saying sound has much to do with vibration of particles. We now want to look at types of various waves, and the reason as well we are talking about waves is we have said that sound is a wave. Sound is a wave, and that is where we must understand what a wave is, the characteristics of a wave, and the terms that are associated with various waves. So we can now look at the types of waves. We have got longitudinal waves. A longitudinal wave is a wave in which particles of the medium vibrates back and forth in the same direction in which the wave is moving. So a longitudinal wave is a wave in which particles of the medium vibrate back and forth in the same direction in which the wave is moving. It's very clear as it is, and we have said sound is all about vibration of particles. The categories come in depending on how the particles are vibrating. If the particles are vibrating back and forth and in the same direction in which the wave is traveling, then that wave is categorized as a longitudinal wave. And by design, sound waves are categorized under this category, that sound waves are longitudinal waves. So longitudinal waves, of course, can be given an example of a sound wave. We move to the second category, which is transverse waves. A transverse wave is a wave in which the particles of the medium vibrates up and down at right angles to the direction in which the wave is moving. So if the particles are vibrating at right angles and they are moving up and down, and of course that one qualifies it to be a transverse wave. So having now discussed the two types of waves, we want to look at the various terms which are associated with the waves. The first term is basically that is what we are calling characteristics of waves. So the first characteristic or property or term, whichever way you may want to put it, the first one is the amplitude. You can see I've drawn an x-axis and the y-axis. This is the y-axis and this is the horizontal axis. This is the vertical axis. If you have a wave, and in most cases a sinusoidal wave, sinusoidal wave meaning a sine wave, which repeats itself after a particular point, you can see the maximum displacement from the horizontal axis is what we are calling the amplitude. The maximum displacement of a wave from the horizontal axis is what we refer to as the amplitude. And it has been defined there. We move to the second one, which is period or time. Period, it is the time taken by a particle to complete one oscillation. So if it takes 5 minutes to complete one oscillation, of course that becomes the period. The next characteristic is the wavelength. The wavelength is the distance between a crest one crest to another crest. Remember, this is called a crest. This is called a crest. This also referred to as a trough. These are called troughs, and these are called crests. So these are crests, these are trough. So the distance between one crest to another crest is what we call a wavelength. You can also decide to use the troughs. So the distance from one trough to another trough, of course, gives us the same dimension, which is the wavelength. Remember, wavelength is denoted by this symbol, which is lambda. The next one we want to discuss about is speed. Speed is another characteristic of a wave, and we have said speed is normally given by the distance covered per unit time. So we know speed is equal to distance all over time. In this case, we are going to denote speed to be represented by v. Our distance will be represented by lambda, and our time can be represented by small letter t. So this gives us a formula of this kind, t. So meaning the speed or the distance lambda can be given by the velocity times time. Another very important characteristic that we have not mentioned here is frequency. So frequency is another critical point. Frequency, which is denoted by f. What is frequency? Frequency is normally given as a 1 over time, which basically means it is the number of oscillations that are made in one second. The number of complete oscillations you make in 1 second is what we refer to as frequency. And frequency is equals to 1 over time. Remember, if you substitute this formula here, then we can say that lambda, which is the distance, is given by v times 1 over. We can make this the subject of the formula. If you make time the subject of the formula, time will be given by 1 over f, meaning if you bring this one to the other side, our lambda, which is the distance, will be given by v 1 over f. And basically this gives us the speed will be given by f lambda. This is another very important formula that you need to know. So this is the much we can discuss for this class. Remember, it's all about sound, and we have said sound is the vibration of particles. We have looked at the various characteristics, and we are going to stop there. Thank you.